Systems of three linear equations with three variables can be solved by substitution. We solve one of the equation for one of the variables and substitute to the other two equations. Those two equations will be reduced to two equations with two variables, which we can solve using either substitution or elimination method for system of two equations with two variables. So let's look at the example. We need to solve the system that consists of the equations x plus y minus z is equal -1, 2x minus 2y plus 3z is equal 8, and 2x minus y plus 2z equals 9. The first thing we'll have to choose an equation and the variable we want to solve for. We want to choose the equation that is easiest to solve for that variable. If you look at this system, you can see that equation 1 is easiest to solve for either x, y, or z. So let's solve it for x. We'll get x equals -1 minus y plus z. That x is now substituted to the other two equations. So instead of x, we'll have -1 minus y plus z, and then we'll have -2y plus 3z is equal 8. And we'll do the same with the third equation. X is substituted with the expression -1 minus y plus z. And then we'll have minus y plus 2z is equal 9. The second and the third equation can be simplified. So we'll get x equals -1 minus y plus z. And the second equation is going to be -2 minus 2y plus 2z minus 2y plus 3z is equal 8. And the third will be -2 minus 2y plus 2z minus y plus 2z equals 9. So the last two equations are now equations only where variables are y and z. Combining like terms, we'll get -4y plus 5z equals 10. And the second equation will be -3y plus 4z is equal 11. We have system of two equations with two variables. We'll solve it by elimination. So we'll multiply the first equation by 3. And the second equation, we multiply both sides by -4 to match the coefficient of y. The first equation will become -12y plus 15z is equal 30. And the second equation will be 12y minus 16z is equal -44. Adding those equations side by side, we'll get y term to disappear, and we'll have -z on the left equals -14 on the right, and therefore z is equal 14 after multiplying both sides by -1. So we got value of z. Now we'll take the value of z and substitute to one of the equations in the system of y and z. So for example, to the second equation, we'll have -3y plus 4 times z, which is 14, is equal 11. That gives me -3y is equal 11 minus 56. Or -3y is equal -45, and therefore after dividing by -3, we'll get y is equal 15. So since we have the value of z and the value of y, we can use the first equation that we solve for x and find the value of x. the x is going to be -1 minus y, which is 15, plus z, which is 14, and therefore x is equal -2. We solve the system, we got values for x, y, and z that will satisfy each equation. The solution of the system is a triple of numbers. X is equal -2, y is equal 15, and the z is equal 14.